I'm not Alan Schreiber, but he's going to be next. Okay, so thanks for invitation to talk about some of our resistance work in botrytis. And so this is a big effort, a team effort. It's been a lot of people involved. I've listed them here. Dave Dutton works in the lab primarily on this project in Pullman, and then you've just met Delphi. She's been involved in this. Olga Bojar's here as well, a PhD student, and a number of student helpers, non-student helpers. Fundings come from the Washington Blueberry Commission, Washington Red Raspberry Commission, Washington State Commission on Pesticide Registration. We have a block grant, a specialty crop grant from the state of Washington, as well as the Blueberry, BC Blueberry Council has supported this work. So we've been interested in these 5 fungicides. These are the 5 main ones that are used to control botrytis in berries. Most of you are familiar with these. I've got the trade names listed down here, okay, and these are the active ingredients. This is the mode of action, and then also the FRAC group. So the fungicides grouped by mode of action is very important. Pay attention to that. We'll talk about a little bit later on about some other representatives of this FRAC group 7, which are really interesting. So these are the main fungicides we've been interested in. We incorporate the fungicides into agar medium, grow the fungi on the medium, measure the growth relative to a control. Last year we sampled, I'm just going to show you data from blueberry, but the situation in other berry crops is very similar. So we sampled blueberry in 2015 as well as a number of other crops. These are the fields. So we sampled 3 blueberry fields in Skagit, 1 in Island County, and 4 in Whatcom. And you can see here I've color coded them. So these are the Skagit, this is Island, these are the Whatcom fields. We also paid attention to the type of management that was going on in those fields. So we sampled a few of what we call low input fields. These are receiving relatively low fungicide inputs versus conventionally managed fields with higher inputs. So those are the fields we looked at for blueberry in 2015. These are the results. So I'll focus only on fenhexamide, boscalid, and saprodinil. We haven't found any resistance, any evidence for resistance to fludioxonil, so that's the one component of switch, or to iprodione yet. So I'm just focused on the 3 where we're seeing resistant isolates. So those are listed here: fenhexamide in blue, boscalid in red, saprodinil in green. The solid parts of the bars refer to isolates that are sensitive to those chemicals, that chemical. The hatched bars are the isolates that are resistant. We verified this with a fruit protection assay where we treat with field rates of the fungicide, inoculate the strains to make sure that, can we protect the fruit against those strains or not, to classify these as sensitive or resistant. And what you can see is that, so the fields that we sampled are listed across the bottom here. So here's Skagit County, Whatcom County fields. What you can see is a lot of variation for each of the chemicals. There's a lot of variation from field to field. So for your example, we have about 20% resistant strains. Here's 0, here about 70%. So a lot of variation field to field, and that's a pattern we've seen across all of the berry crops as well. Same for boscalid, so we have a lot of variation. Same for saprodinil, lots of variation field to field. We see a strong correlation with, as you might expect, between the management program, so the inputs of fungicides, and the resistances that we see. So here are those 2 low input fields. Okay, so you can see that, for example, the frequencies of resistance is very low in this particular field, a little bit to saprodinil, but really essentially none to boscalid, none to fenhexamide. Same for this field. So that we've seen this again, this pattern's repeated many times over in all of the berry crops. So we looked at those fields where we know that there are low fungicide inputs, we see generally much lower levels of resistance. Okay, so to summarize this part, so we don't see any evidence of resistance to fludioxonil or iprodione across all the Pacific Northwest. So this is Washington, British Columbia as well. But we do see resistance to 3 of the 5 chemicals. Some fields have high frequencies of resistance to all 3. So we see widespread resistance to for the, by reducing the use of these chemicals, reduce the selection for resistance. We see a large variation in field to field, which I find really interesting. Olga is going to be following this up with some other kinds of molecular markers to see. It looks like Botrytis really doesn't move very far. It's very local population, so we're going to be interested to test that with some other markers. And of course, there's a clear correlation between how much those fungicides are used and that the response is the selection for resistance that we see. Okay, so what I've been doing recently, so remember that we've had high frequencies of resistance to boscalid generally across all berry crops. So these so that's in group 7, FRAC group 7. So these are the succinate dehydrogenase inhibitors, or SDHIs. Boscalid resistance widespread, it averages about 70% across berry crops in the Pacific Northwest. I've listed some of the other chemicals, the other new FRAC group 7 chemicals that have become available here. So they include isofetamide, adepidine, flopyram, penthylpyrad, fluxapyroxad. These are some of the trade names and then the manufacturers here. The manufacturers claim that these new chemicals, even though they're in group 7, so normally you'd expect if it's FRAC group 7, those would not be able to, any other chemical in FRAC group 7 would not be able to control boscalid resistant strains because they're in the same FRAC group, same mode of action, okay? Claims with the manufacturers are that they do, so that this is unusual. So that normally we say we have to pay attention to FRAC group because of the cross resistance within FRAC group, within each FRAC group. The mechanisms known, so we know about some of the mutations for boscalid resistance and resistance to these other chemicals in the target site. So we know a lot about that, which is really, really good. And so what the prediction then is, if these chemicals are going to be effective in controlling strains that are resistant to boscalid in our area, we need to know what boscalid resistant mutations we have, okay? So what I did was to take a sample of boscalid sensitive isolates and resistant isolates from the Pacific Northwest. This shows the EC50 calculation. So this is just a detailed way of estimating how resistant the fungus is. This is the distribution you see. So you have a number of isolates down here in this range with EC50s of say 6 or 7 parts per million or less. So these are isolates that are sensitive to boscalid. We verified this with our fruit assay. From about 10 parts per million up to into the 500 parts per million, these are the resistant strains. So there's a lot of variation in their sensitivity to the chemical, wide range. This is what people have seen in other systems as well. It's not unusual, but lots of variation in these resistant strains. So we know the cutoff is about here. When I take these boscalid resistant and sensitive strains from this area and tested them against adepidine, these EC50s fell out here, about 1 to 3 parts per million or so. Okay, so this includes both boscalid resistant and sensitive strains from this area. Same pattern for isofetamide, about 1 to 3 parts per million. Flopyram's a little bit different. A bulk of them are in this range down here, but there's a few that are a little bit higher, up in the sort of 9 to 10 parts per million range. Same for penthylpyrad, very similar distribution. Okay, so we're not seeing any strains with the really high EC50 values that we see for boscalid. The bulk of the EC50 values, sensitivities are low down in this range here. So this is really interesting. So just before I show you, I'm going to show you some graphs that sort of graphically depict cross resistance, and this is how we think about cross resistance. So if you have increasing resistance to a fungicide, let's call it fungicide A on this axis, okay? Increasing resistance to another fungicide, different fungicide here, let's call it B on this axis, so going up. This is the pattern you see when you have cross resistance. So you have a number of individuals who are sensitive to both, okay? Number that are, and then another population that's sensitive, that's resistant to both. and you have a strong positive correlation between them. So that's the standard prediction from within a frac group. For example, you'd see if you take one chemical, if you have a resistance to it, you substitute another one from the same frac group, this is the pattern you'd expect to see. Okay, so generally within the same frac group, they're cross-resistant. So this is what we see when we plate, when we compare boscalid sensitive and resistant isolates. So here are the boscalid sensitive isolates. Here are the boscalid resistant isolates, these two populations here. Okay, this is on a single concentration of boscalid, 5 parts per million. These are all the resistant strains, these are sensitive. What you can see is there's no correlation between the sensitivity to boscalid and to flopyron. Okay? Slightly negative relationship. Same for isophetamine, same response. So none of the mutations that are conferring resistance to boscalid do not appear to confer high to resistance to these other two chemicals. Excuse me, the pattern is a little bit different for adepidine. So it's a slightly positive relationship. So again, we're screening on a single concentration. So this is 1 part per million adepidine over here, 5 parts per million boscalid again, sensitive and resistant to boscalid. Slightly positive relationship. Same for penthiopyrad. So we have these two, looks like two families of relationships. This type down here where we have a slight positive correlation, and then here where we appear to have none. So what we want to do next is to screen some of these isolates that are the most insensitive, say to adepidine, okay, down to the least sensitive, down to the most sensitive, across here in our fruit assay to see what this variation represents. My hunch is that based on how the amount of growth at these low concentrations, that all of these chemicals may potentially control boscalid resistant strains, or at least the strains that we have in this area. So I think that's pretty exciting news. Okay, so next what we're going to do is to screen a larger number of isolates. This was fairly preliminary data. It was about 30 to 40 isolates or so sampled from different berry crops across the region. So we want to screen a larger sample. We've got a few additional chemicals we'd like to test. We want to relate that to our field, to our fruit assay to see what that variation represents, whether we're able to control them using field rates. And hopefully this will, Alan's going to talk about some of his efficacy data next. And so hopefully we can use that to support some registrations for these chemicals, give you more options for control. So I guess we'll leave the questions till the end. Okay.
All right, so I'm going to talk about some of my field work, but first, I'm telling you, it's really good to have plant pathologists of the caliber of Tobin Peaver and do work like that. It's very, very useful, very helpful for us and for the work I do. Unfortunately, I hate to have to follow him on a plant pathology talk, but we decided that I was going to yield half my time for him so he could talk about that very interesting work. So I'm going to have to really push through my presentation. So here's the short story. I did 2 efficacy trials, small plot work. They're in Skagit Valley. We had 30 treatments. We broke them into two trials, about 15 treatments in each one. This is a field that previously was organic. It is now conventional. One of the significance of that is because there's not been a history of fungicide use, we do not have resistant botrytis. So this is susceptible botrytis. And we also had mummyberry in it. Oh, look at this big long list, too small to see. So I put it into a program. So this is an untreated check. This would be 4 applications of Indar, 2 applications of Pristine. This is 4 shots of Orbit, 3 shots of Switch. So this is a mummyberry and botrytis program. This is a new product, Quash, followed by Switch. This is just straight Pristine. This is 5 shots of Roverol, which is 1 more than the label allows. This is 6 shots of chlorothalonil, 6 applications of Captan. This is a new fungicide, not yet registered, Luna Tranquility, a new Propulse, Proline. This is a program of Roverall, Top Guard, Roverall Pristine, Fracture. This is kind of an FMC program. This is straight Fracture, a new fungicide, Top Guard, a new fungicide, again, not registered. And then we had Roverall, Fracture, Top Guard, Pristine, Top Guard. And when you look at what worked best as far as Mummyberry strikes of flowers and leaves, the most effective program we had was an Indar Pristine and Proline, which gave perfect protection of the flowers and leaves, followed by Fracture and this Top Guard. Now, Top Guard is a product probably nobody has heard of. This actually is a product that's very similar to Indar. It's a group 3 triazole. It's related to also Quash, followed by Switch was very effective. Propulse, this Orbit Switch program, this FMC program, Luna Tranquility, Pristine, and most of these products gave commercially acceptable control of Mummyberry. If you look at the infection here, this is actually infected fruit. The Proline, Propulse gave perfect control. Luna Tranquility, the Quash, Switch, Pristine, a number of these products gave pretty good control. What did not give as good a control is Captan, Roverall, and chlorothalonil were the poorest performers in this trial. When we looked at Botrytis, Botrytis pressure was very light. If you remember, it was pretty warm, not much moisture, so we didn't have much. Here's 4.3, the untreated check. But the most effective products, Luna Tranquility, again, not yet registered, but will be registered in berries. The Indar Pristine, Propulse, the Orbit Switch, and Roverall Pristine were all the best performers. We did a second trial with a different group, same location. Again, it's the Skagit Valley, same experimental design. We had a lot of active ingredients involved, but when you collapse it down into the individual 15 treatments, we had untreated check. We had a program with basically Bravo, Indar, Proline, Switch, Pristine, Abound, and Elevate. So this is kind of like a full meal deal, a commercial program, season long. This is Meteor. Meteor is generic iprodione. So this theoretically is the same as Roverall. We have Topsin, M, rotate with Meteor. Torino, a product not registered on Blueberries. It's one you've never heard of before and has not been tested on Blueberries. So we're out looking for some new kinds of products. We had Kinja, low rate, Kinja at the high rate, Switch, Kinja followed by Omega. Then we had a Bravo, Indar Switch, Indar Pristine Switch. And then we had products Oso at the low rate and Oso at a high rate. When you look at those products, on flower and leaf strikes on May 3rd, the multiple active ingredient heavy duty program was the most effective, as well as a Bravo Indar Switch. Meteor was very effective, as were the 2 Oso products. Indar Pristine Switch, Tops and Meteor were also in the effective group. Kinja, who had never, as far as I know, Krisky, are you in here? Right here. So this is the Kinja rep. As far as I know, this is the first time Kinja had looked at for Mummyberry, and it has some Mummyberry activity, but it doesn't look like it's gonna save the day. When we look at actual infection on fruit, this multi-active ingredient program worked, as did Switch, Topsum M with Meteor, the Indar, the high rate of Oso, low rate of Oso, this Bravo Indar Switch, and Meteor have activity. And Kinja was so-so. The Trino just didn't work. Now, when you look at Botrytis, again, in this trial, Botrytis was quite low, and it was the heavy-duty program. It's kind of like a Cadillac program, worked well, as did Meteor, the high rate of Trino, Kinja with Omega, but we know Kinja is pretty effective on Botrytis, Switch, and then these programs. So when you look at this last program, if it's in orange, this is something that's commercially gave very good control. Bravo, the Indar Switch, Oso, Pristine. again, this is when this is in a field that does not have resistance. If it was black, that means it had moderate activity against Mummyberry, and that was Kinja. And the Trino just simply did not have activity. And I suspect that's a fungicide we will not see on blueberries. So a few thoughts about Mummyberry. I don't know if you guys really absorbed this. That was a 7-minute whirlwind tour of 2 big trials. What is interesting, iprodione product that was Roverall did not work on Mummyberry, but the same product, different formulation, Meteor, was effective. So I don't know why one of those iprodiones would be effective against Mummyberry and the other one wouldn't be, but this is the 2nd year in a row that this product Meteor has had activity against Mummyberry. I presented a presentation yesterday where we looked at OSO and an organic trial. And in the organic trial, OSO was not very effective against Mummyberry, but it was very effective in this trial. And the reason for that, we believe, is in the organic trial, there were a number of products that didn't work. And as a result, these, a lot of plots, like something like OSO, was surrounded by treatments that didn't work. And I think in a very heavy pressure situation, OSO may not be very effective. But in the conventional trial, most of the products work. And so I think in a lower pressure situation, OSO would be effective. There's also another product called Fracture that didn't work in the organic trial, but did have some efficacy in the conventional trial. And I think it's the same situation. Both of these products are kind of a little bit towards the biofungicide direction, and they're not highly efficacious, but in a low to moderate pressure situation could give commercially acceptable control. Products that were most effective against Mummyberry were Meteor, Proline, Propulse, OSO, Luna Tranquility, Indar, Pristine, and some of the combination program treatments. Top Guard was a very interesting product. It had some good efficacy, but it is a group 3, and it is in the same group as Indar, Orbit, and Proline, and probably does not bring much new to the table. It's just another group 3 product. The ones that didn't work very well were Captan, Roverall, and Torino. And remember, Trino is not registered on blueberries. Kinja was intermediate in this first trial against Mummyberry. I would like to look at that as 2nd year. Regarding Botrytis, pressure was low, which limits the conclusions we can draw. Ones that did not provide a high level of control were Fracture, Top Guard, Bravo, low rate of OSO, and the low and intermediate rates of Torino. Products that gave better control, and remember this is without resistance, was Meteor, Luna Tranquility, Propulse, Proline, Captain, Switch, Pristine, and the program treatments. Now, we also did a Botrytis trial in Blackberry, and I want to bring this out to some people because there's something in this trial that is very, very interesting. Blackberry is a kind of a high pressure Botrytis crop, or at least this variety was. It was Chester. It's a late maturing variety, so it's fruiting during the cooler, wetter season, and it's when Botrytis is at its worst. And in this field, there had been documented resistance to cyprodinil, finheximide, and boscalid. Dr. Peaver and I have a little difference of opinion about, he says there's no resistance to iprodione, and I am going to stand up here in front of everyone and says I disagree with him. Now, tell me, we had resistance, widespread resistance. We stopped using iprodione in the mid-90s, and how can you say there's no resistance in these populations when we had documented resistance in the past? So it went away. The genetics are still out there in the population. You'll never get a hold of the genes, get rid of the genes. So if we use Roverall, it's going to come back, right? So it's there. You're just saying it's not, the genes aren't common enough to cause field control failures. All right. So I want to talk about this trial, because what I'm concerned about is ever since we started doing efficacy trials, in 2012, we had a train wreck with Botrytis, and we had widespread control failures to a lot of products. Ever since we started doing efficacy trials, it's been dry, and disease pressure has been low. But one of these years, we're going to go back to having a lot of rain and cool temperatures during the raspberry growing season, and we're going to have a botrytis train wreck. It's just a matter of time. And I just want to show you something about this Blackberry trial. Now, this is some efficacy data of a number of products. And I just want to point out that the untreated check is down here. This is ranked best to lowest. We had Rovrol, Iprodione performing equal to or slightly poorer than the untreated check in this trial. And we had 8 applications of Rovrol. 8 applications of Rovrol, and it did nothing. It had provided no benefit. Switch, Elevate, and Pristine, all which have documented resistance in this field, were no better than the untreated check after 8 applications. And my concern is this is what could happen in fields that have resistance if we get into a heavy pressure situation. When the pressure has been medium, moderate, or light, and low, like it's been the last few years, a lot of these products will work. But if you get in a heavy pressure situation, it could get ugly. Now, what worked well? Here's Fontellis. That was the most effective product. And that's one of the ones that he was just talking about, that he did the plate studies on resistant lines of botrytis, and it worked. And here's a field situation where it worked against a field of population that's known to be resistant. We also had Luna Tranquility with Captan and Serenade. I can assure you the reason it did as well as it did was because of the Luna Tranquility, not because of the Captan and the Serenade. But this, again, is one of these group 7s that's supposed to not have cross-resistant to boscalid-resistant botrytis. Omega also did pretty well. And real quick, what's the frat group of Omega? Flazinam? I can't remember, but it's not 7. It's a different mode of action. And Kinja also had activity as well. That's another one of these group 7 products that doesn't have cross resistance. So I think we have dodged a bullet on being able to control, not having crop failures because of control failures, because we've had some light pressure. But if we have pressure in raspberries like we do in later season in blackberries, we could have situations where Pristine, Elevate, and Switch and Rovrol simply do not work. What's that? Okay, Omega's group 29. Okay, and we're gonna still 1 minute. I need to have a little Kinja talk. Kinja rep, when are you gonna get a registration for Kinja? Raspberries, blueberries, and blackberries. In June of 2017, so we have to go for a Section 18. When are you going to get us the tolerances for Japan and Taiwan? Why don't you go to the microphone?
Okay, so I don't have information on Taiwan and Hong Kong. I do have information on Japan, which will be the end of 2017 for grape, strawberry, blueberry, and caneberry will be March of 2020 expected.
March of 2020? Fire somebody. We need it sooner than that. What about strawberry? You said strawberry's end of 2017?
Yes.
Okay, so we got to go for a Section 18, and we'll have some MRL for Japan. We already have for South Korea.
Korea, yes, until 2018.
What do you mean until?
Well, they are using the grape. We have a grape registration in Korea. They're using the grape tolerance for all very small fruit, but that's going to go until the end of 2018. And then we are working on a new tolerance for the rest of the berries.
Are you going to have it by 2018?
I don't have an answer to that.
You guys are leaving a lot of money on the table by not having your MRLs in place. We could be using a lot more of your product. We would like to use a lot more of your product.
I understand.
All right. Okay.
So I think we're a little bit over time, and if you have any more questions, I think you can give it off stage. And I missed one introduction to Dr. Tobin Peaver. So thank you, Dr. Tobin Peaver and Dr. Alan Schreiber. This is